بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. This is section 1.3 and it's about matrices and matrix operations. A matrix is a rectangular array of numbers. The numbers in the array are called the integers of the matrix. So these numbers inside the matrix are called the integers of the matrix. These are some examples of matrices. You can find the size of each matrix by looking to the number of rows and the number of columns. For example, the first matrix has 1, 2, 3 rows and 2 columns. So it is a 3 by 2 matrix. We say a 3 by 2 matrix. While this matrix has 1 row and 4 columns, so it is uh, of size 1 by 4. Can say it's a row matrix. So this is a 3 by 3 matrix. This is 2 by 1, and this is 1 by 1. So this is called the size or the order of the matrix. A matrix A with n rows and n columns is called a square matrix of order n. So this is a square matrix of order 3. And the shaded integers A11, A22, ANN are called or on the main diagonal, are said to be on the main diagonal. So this is the main diagonal of a square matrix. We call them A11. This means the entry in the first row, first column. AN2 means the entry in the nth row, second column. We can give the entries inside the matrix. We can write them like this: A11, A12, which mention their position. Where is their position in the matrix? Two matrices are equal if they have the same size and their corresponding entries are equal. They must have the same size and corresponding entries are equal. Means if these two matrices are equal, then A equals to 4 immediately. And 3 equals to D minus 2C. And -1 equals to D plus 2C. And you notice here that we have a system of two equations in two variables. We can solve the system by elimination or addition method. If we add the two equations, we will have 2D equals 3 minus 1, which is 2. So D is 1. And then we can replace D by 1 anywhere in the first equation. 1 minus 2C equals 3. So -2C would be 3 minus 1, 2. So C is -1. So we have A, B, and C. He needs to solve for all the letters. The last one, A plus B, is -2. We know that A is 4. So B would be -2 minus 4, -6. So we solved for all the letters because the definition of the equality, because the two matrices are equal, means the corresponding entries are equal. We can add two matrices of the same size. We can subtract two matrices of same size. We can multiply a matrix by a constant, any number. That's usual. For example, let me solve this question here. Use the following matrices to compute the indicated expression. If it is defined, well, I have D, size of D is 3 by 3. I want to add D with 2E. E is also 3 by 3, so I can do that. So this would be -3 times D. which is 1, 5, 2, negative 1, 0, 1, 3, 2, 4. Now, how would you write 2e? 2e means the number 2 is multiplied by the matrix E. This means you multiply each entry in E by 2. So you will have 12, 2, 6, negative 2, 2, 4, 8, 2, and 6. And now we can add these two matrices because they have the same size by adding the corresponding entries. So 1 plus 12, 5 plus 2, 2 plus 6, negative 1 plus minus 2, 0 plus 2, 1 plus 4, 3 plus 8, 2 plus 2, 4 plus 6, and then you can multiply each entry by negative 3. So negative 39, negative 21, negative 24, 9, negative 6, negative 15, negative 33, negative 12, negative 30, and this would be the answer. So this is how to add or multiply a matrix by a scalar, by a number. And we call it a scalar, real number. Okay, what about multiplying two matrices? Can we multiply, can we find A times B here? And can we find B times A? Okay, so in fact, we can find A times B here because the size of A, 2 rows, 3 columns, and the size of B, 3 rows, 4 columns. So we have 3 columns in A and 3 rows in B. So we can find the product. We can perform the multiplication. And the size of the product, the size of AB would be 2 by 4. So this is what we have here. To multiply two matrices, R should be R. These two should be equal, and the size of the product should be M by N. Now, how do we multiply the two matrices? We multiply the first row of the matrix A by the first column of the matrix A. So 1 times 4, that's 4, plus 2 times 0, that's 0, plus 4 times 2, that's 8. If we add these numbers, we get 12. So the first entry here is 12. So this entry, what is the position of this entry? It is in the first row, first column of AB. To find it, you need to multiply first row of A times the first row of B. So for example, we said that AB had 2 times 2 by 4, so 2 rows and 4 columns. So like this. Assume that I need to find this number. What is the position of this number? Second row, third column. If you want to find this number, you need to multiply the second row of A by the third column of B. 2 times 4 is 8. 6 times 3 is 18, and 0 times 5 is 0. 8 plus 18 is 26. So the answer is 26. So this number is 26. I hope you got the idea. But here, I don't want to find a specific number. I need to find all AB. So how would I do it? I will multiply the first row in A by all the columns of B, one by one. And this will give me the first row in AB. So 124 times 402, I got 12. Now let us multiply 124 by 1 minus 17. 1 times 1 is 1. 2 times negative 1 is negative 2. 4 times 7 is 28. So the answer is 27. Okay, 27. Let us remove these points. So this is 27. Now the next number, multiply 124 times 4335, the third column. So 1 times 4 is 4, 2 times 3 is 6, 4 times 5 is 20, so this is 30. And finally, 124 times the last column. 1 times 3 is 3, 2 times 1 is 2, 4 times 2 is 8. I have 30 in here. So I finished the first row. The second row, multiply the second row of A by all the columns of B. So 260 times 402. I have 8 plus zeros. 2 times 1 is 2, negative 6, that's negative 4. And we evaluated this one. So the last number would be 2 times 3, 6, plus 6, that's 12 because the last number is 0. So this is the multiplication, the product of the two matrices. Of course, notice that BA is not defined. So I cannot multiply B times A. BA is not, I cannot perform this product. Why? Because I have 3 by 4. This is B. If I multiply times by 2 by 3, I can't because 4 is different than 2, so I cannot perform the multiplication. So BA is not defined. So you can understand from here that in general, AB is not equal to BA. So the product of matrices is not commutative. There are certain cases in which they are equal, but in general, they are not equal. Transpose of a matrix. If we have a matrix A, how can we find AT or A transpose? We take the first row of A and write it as the first column in AT. The second row in A, write it as the second column in AT. The third row in A, write it as the third column in AT. So we are just changing rows in two columns. At the end, you will find that you have 176, 176. The main diagonal entries are not changed, but these numbers are changed, interchanged around the main diagonal. So I have negative 2, 3. I'll have here 3, negative 2. I have 4, negative 5. I'll have negative 5, 4. I have 0, 8. I'll have 8, 0 in the transpose. So this is the transpose of a matrix. Let us solve question 5 here. He needs to find CT times B times AT. Okay, let me check the dimensions first. What is the size or the order, the dimension, size, order, all the same meaning? C. What is the size of C? Well, the size of C, 2 rows, 3 columns, so 2 by 3. So what would be the size of the transpose? It would be 3 by 2 because the rows will be columns and the columns will be rows. So C is 2 by 3. CT would be 3 by 2. What about B? B, 2 by 2. Good. So I can perform this multiplication. No problem. And the product will be 3 by 2. This would be the product of these two matrices, 3 by 2. Now I will multiply the answer, the result, by AT, by the transpose of A. Okay, what is the size of A? 3 rows, 2 columns, 3 by 2. So AT would be 2 by 3. So I will be able to perform the multiplication because I have 2, 2, and the result would be, uh, the size of the result matrix would be 3 by 3. So at the end, this matrix, the size of this matrix, the answer would be 3 by 3. So let us do it. So I can perform the multiplication. So let us do it. First, CT. This is C. Let me write CT. 1, 4, 2 is the row. I wrote it as a column. 3, 1, 5 is the second row. It would be the second column. Times B. So let me write B. B is 4, negative 1, 0, 2. I will multiply these two first, and then I will multiply by AT. Well, this is A, so AT would be, change the rows into columns, 3, 0, negative 1, 2, 1, 1. So let us multiply these two. 1, we said that this is 3 by 2, and this is 2 by 2, so the answer would be 3 by 2. Okay. 1 times 4 plus 3 times 0. 1 times negative 1 plus 6. I finished from the first row. The second row, 16 plus 0. 4 times negative 1, negative 4 plus 2. 2 times 4, 8. 2 times negative 1, negative 2 plus 10, also 8. So this is the product of CTB. I multiply the answer by 3, 0, negative 1, 2, 1, 1. Now this is a 3 by 2, and this is a 2 by 3. So the answer would be 3 by 3. So let us multiply the first row by the first column, 12. First row by the second column, negative 4 plus 10. First row by the third column, 4 plus 5. Now go to the second row, 16 times 3. 16 times negative 1, negative 16 minus 4. 16 minus 2. The last row, 24. Negative 8 plus 16. 8 plus 8. So this is the answer. The last point in this section would be the trace. How to find the trace of a matrix. Notice that the transpose of a matrix is another matrix, while the trace of a matrix is a number. And the matrix here is a square matrix. So there is no trace of A, for example, here. I cannot find the trace of A here, or C, but I can find the trace of B, D, and E. Is defined to be the sum of the entries on the main diagonal of A. So add the entries on the main diagonal. So what is the trace of B? 6. What is the trace of E? 10. What is the trace of D? 5. The trace is undefined if it is not a square matrix. So here I need to find 4 times the trace of 7B. So 4 times the trace of 7B, well, this is B, and let us multiply by 7. So I'll have 28, negative 7, 0, and 14. So I have 4 times the trace of this matrix. What is the trace of the matrix? Add the numbers on the main diagonal. So 28 plus 14 means the 42. Okay. And 4 times 42 is 168. Okay. So that's the answer. So whenever there is a trace, your answer would be a number. Trace d times dt. Okay. What is d? Where is d? This is d, 3 by 3. Okay. So it would be 3 by 3 and dt is 3 by 3. So I can evaluate the product. 1, negative 1, 3. 5, 0, 2. This is the matrix D, and 2, 1, 4. I will multiply this by dt, the transpose of this. So the first row, write it as first column. The second row, the third row would be the third column. So I need to find the trace of the following matrix. Multiply the first row by the first column. 1 plus 25 plus 4, that's 30. Notice here, I just need the trace, which means I need the numbers on the main diagonal. So why should I multiply these two matrices? I need only these 3 numbers on the main diagonal. So I found this one, I need this one. How to find this number? It is in the second row, second column. So multiply the second row by the second column. Negative 1 times negative 1, 1 plus 0 plus 1. So this number is 2. And now I need this number only. The third row, third column. Multiply the third row by the third column. 9 plus 4 plus 16. That's 29. 9 plus 4 plus 16, 29. So what is the trace? 30 plus 2 plus 29. So 32 plus 29, and this would be 61. That's the end of this section. I hope you understood the main ideas. These are the main ideas in the section. Have a nice time.